So now we are studying about galvanometer. So what is the function of galvanometer? It is used to measure very small amounts of current. Okay. So currents greater than certain value cannot be measured by galvanometer because it breaks down. So very small amount of currents can be measured with the help of galvanometer. So let us see what is the basic construction of this one. So here we have two magnets which provides the magnetic field, and we know that magnetic lines of force, they travel from north pole to south pole. Clear? And in between this gap between these two poles there is an armature. So on this armature we can find the windings which are present, or coils which are present. Clear? For example, if this is the armature, clear ma? So on this armature you can find windings which are present. So like this windings will be present. So through these windings only we make the current to pass. So therefore when current passes through these windings which are present on the armature, then it is just like a current carrying coil placed in a magnetic field. Okay. So when a current carrying coil is placed in a magnetic field, it experiences a torque. So because of this torque, this armature starts rotation. Okay. And depending on the strength of the current which is passing through this armature, the rotation of armature also depends upon. And to the armature there is a needle which is fixed, and that needle will show what is the amount of deflection which is produced on a scale. Okay. So there is a scale also which is present, so this needle will show what is the reading on this scale. And because the needle should again return back to its original position, so we attach this needle to a hair spring or a coil spring which provides an anti-torque or an opposite torque by which the needle again returns to its original position. Okay. So this is the method of measuring very small amount of current by using galvanometer. Okay. Okay. Now Sima, previously we studied galvanometer, no? How galvanometer works. And what is the disadvantage of galvanometer? Voltmeter. So based on this you may get one question. Are you able to understand now? See here. So galvanometer has small range, ammeter's range is battery. Are you able to understand? So in this circuit I want to measure that. Then what I have to do? I will connect this ammeter in series. Ammeter must be connected in series. Are you able to understand? See ma'am, because ammeter should be connected in series, so how to convert galvanometer ammeter is, this is the method. This is the galvanometer. Previously we have drawn a diagram, no? That total is represented by G here, galvanometer. To this galvanometer we have to connect a very small value of resistance of shunt is very small when compared to resistance of galvanometer. Galvanometer resistance is also very small. Galvanometer is almost 0. దీని resistance ఇంకా చిన్నగా ఉంది. Why this resistance should be so small? And it is connected in series to galvanometer or in parallel? Series to parallel on the it is in parallel to galvanometer, no? Now we are saying that this resistance should be very small. Resistance of the shunt, I will write here. Shunt resistance should be less than galvanometer resistance. What is S, what is G? S is the resistance of shunt. G is the resistance of galvanometer. Are you able to understand? When compared to this resistance should be very small. What can be the reason? Yendukala. Chapandi, anybody? Can you say? What can be the reason that this resistance should be so small? If you remember these points, then only you can remember ammeter and galvanometer. Otherwise, you will get confused. A bit slightly confusing topic. Okay? Reasoning should be very important. What can be the reason? See, if resistance is very small, maximum current will flow through this shunt only, no? What is Ohm's law? Ohm's law is I is equal to V by R. Clear, no? It means I is inversely proportional to R. If resistance is very small, current flowing will be very large. This is Ohm's law, no? Are you able to understand? So here, shunt is very small. And what is the total current that is flowing in the circuit? Total current is I. So this current, it should get divided into two branches, no? So Ig current flows in galvanometer, and remaining current is how much? Remaining current is I minus Ig. This I minus Ig should flow into the shunt. And already we discussed that galvanometer should measure only small amount of current. It can handle only small amount of current. So remaining total current should flow into the shunt itself. Are you able to understand? And it is possible only when resistance of shunt is very less when compared to resistance of the galvanometer. That is the reason. Because current is inversely proportional to resistance, no? If R is very small, I should be very large. Okay? For example, let us consider 10 amperes is the total amount of current. Out of 10 amperes, galvanometer can handle only understand? Okay, now see. So therefore, now I have here two branches are there, no? Two branches are there. Galvanometer branch is a branch and this is another branch. And these two branches, are they connected in series or in parallel? Parallel, no? Andaru baane unnaru. Ramzan effect andar paina unnatlundi. Arshap almost soyate hai. Nahi? Okay. Clear ba? These two branches, they are connected in parallel, nama. And what is the importance of parallel connection? What is the importance of parallel connection? If two branches are connected in parallel, potential difference across both the branches should be equal. Already we have studied, no? What is the potential difference across galvanometer? Same potential difference should exist across the shunt also. Clear, no? Because these two branches, they are connected in parallel. Are you able to understand? So therefore, I am writing V1 is equal to V2. V1 is the potential difference across first branch. V2 is the potential difference across. And what is the current flowing in the shunt? I minus I. Resistance of shunt. So I minus I. So this is a relation. I can calculate what is the amount of shunt I have to place so that I get a range of current to be I. What is I here? I is the range of current, or you can say I is the range of the ammeter. If you go to engineering, there you will find ammeters. They will have some ranges. So one ammeter will have a range of 0 to 10 amperes. One ammeter will have a range of 0 to 15 amperes, like this. Okay? What is this 10 and what is this 15? Range of ammeter. It means that is the maximum current measured by the ammeter. And that I is nothing but this I. Are you able to see, ma? I is the total current, no? Total current is nothing but that is the maximum current which this ammeter can measure. Okay? So therefore, value of shunt is how much? Ig into G by I minus Ig. You need not by heart any of this formula. You are supposed to understand this relation. Okay? V1 is equal to V2. From the same relation, you will get all the remaining relations. You are able to understand? So this is the equation to calculate the value of shunt required to be connected in parallel to galvanometer. And this total combination is called what? This is called as an ammeter. Are you able to understand? Okay. So therefore, if I do some more calculation on this one, then I will get I value here. And what is this I? This is the range of ammeter. Okay, now what is called I here? So write down here. I is called what? I is called as range. This particular ammeter is called as I. Are you able to understand? Now when you look at this equation, I find that I is inversely proportional to S number. So previously question was asked on this one. It means the range of ammeter. Inversely proportional. Inversely proportional means what? If a shunt is very small, then you can measure more amount of current. Are you able to understand? No? If shunt is very, very small, the amount of current which you measure will be continuous. That is the meaning of it. So lesser the resistance of shunt, more will be the current. Are you able to understand? Completed up to here writing? Okay, no? Now see. Now we will study how we measure current by using this ammeter. Okay, ma? Technique of measurement. Technique of measurement. Okay. So Ig into G is equals to I into S minus Ig into S. So take Ig on one side. If I take Ig common, then it is G plus S is equal to I into S. From this relation, I can also write Ig is equals to I into S divided by G plus S. Clear now? I can write like this. So therefore, from this equation, I understand one point. I understand that Ig is directly proportional to I. Ig is directly proportional to I. This is from this relation, I am deriving a relation between Ig and I. What is S? Shunt. G? Resistance of galvanometer. They are constants, no? If they are made constant, then I see that Ig is directly proportional to I. What is meant by Ig and what is meant by I? I and I, Ig and I. I is the maximum amount of current. Ig is amount of current which enters into galvanometer. Are you able to understand? Ma? So the amount of current entering into galvanometer is directly proportional to I. This we have understood. No? So galvanometer will show what reading? Galvanometer will show the reading of Ig only. No? What is the current entering into galvanometer? Ig. Ig current agada galvanometer. So Ig will measure Ig only. Sorry, galvanometer will measure Ig only. But the point is that Ig is directly proportional to I. No? For example, if I write, let us take one example. Clear? For example, if I write Ig is equals to 2I or Ig is equals to I by 2, then what do you understand? If I write Ig is equals to I by 2, what do you understand? Anybody? So here proportionality constant is half, no? Here proportionality constant is 1 by 2. What is the meaning of this one? So Ig will be exactly half of I. Are you able to understand, ma? So what we do is, in designing galvanometer, we have designed a scale, no, ma? We will design that scale in terms of I instead of Ig. Are you able to understand? So in galvanometer, we have drawn a scale, no, ma? That scale is calibrated such that it measures directly I value instead of Ig value. How can I do that? By just doubling the current or doubling the readings. For example, here Ig is half of I, no? Then what is I value? I value is 2 times of Ig, no, ma? I value is how much? 2 times of Ig. Okay. So galvanometer will measure Ig. That measurement, if I multiply by 2, it converts into I. That's all. Are you able to understand? We are able to do this one because these two are directly proportional to each other. Ig is directly proportional to I. So we make changes in scale reading. In scale calibration, scale ni divide chestam kada manu, our divisions are made such that it directly measures I value instead of IG value, because they are directly proportional. On scale we have this kind of readings, no? This kind of readings, no? Clear? Let us consider 1 division is equals to 1 ampere, for example. If I consider 1 division is equal to 1 ampere for which reading? For IG reading. 1 division is equals to 1 ampere for IG reading. But here, if I want to measure directly I value, then can you say what I have to do? Just 1 division, if I take, instead of 1 ampere, if I take 2 amperes, then directly I am measuring I value instead of IG value. Are you able to understand? Because IG is half of I, or I is 2 times of IG. Are you able to understand? No? This is the technique of measuring I value directly instead of IG value. Clear? So therefore, what is the note point here? We have to write, note point is that, okay. So we calibrate the scale such that it directly measures I value instead of IG value. Instead of IG value. Clear, Nama? That's all. So this completes our topic called ammeter. Ammeter. Ammeter edare. Galvanometer already completed, no? This is the concept of ammeter. Okay? Are you able to understand, ma? So in ammeter, this is the point which you should understand, ma. In ammeter, shunt resistance is very small, first point. Shunt resistance means it is connected in parallel to galvanometer. And its resistance should be very small. Why its resistance should be very small? Because very less current should enter into galvanometer. Total current, maximum current should enter into shunt only. And ammeter, is it connected in series or in parallel? Ammeter is always connected in series in the circuit. To galvanometer, we connect resistor, shunt resistance in parallel. These are the concepts. Clear, no? So you should practice them many, many times. Otherwise, you will get always confused here. Okay? That's it. Right now. So second application of galvanometry is, I want to convert galvanometer into voltmeter. What is the purpose of voltmeter? Stop writing. What is the purpose of voltmeter? Voltmeter ఏం చేస్తుంది? Ammeter ఏం చేస్తుంది? Ammeter measures the strength of current. Voltmeter measures the strength of potential difference. For example, in between these 2 points, I want to measure potential. galvanometer in combination with a very huge resistor, this makes the voltage. Now, so in this circuit, I is the current. You understand? So this becomes the potential difference between points A and B. That's all. So then I can also write Ig is equals to VAB by G plus R, no? So Ig is proportional to V, no? So what do you understand? Galvanometer will measure Ig only, no? Galvanometer then measure chestundi, Ig ni measure chestundi. But we calibrate the scale such that instead of measuring Ig, it measures V. That's all, very simple. Why? Again same concept, because they are directly proportional to each other. Are you able to understand, ma? So galvanometer will measure Ig only, but we devise the scale such that instead of measuring Ig, it will measure V. That's all. That is the technique of performance of voltmeter. Have you understood? Right. So therefore, what we write, technique of measurement. So technique of measurement is Ig is proportional to V. Okay, therefore, scale is calibrated. Calibrated means divided. Scale is calibrated such that, okay, instead of measuring Ig, scale shows VAB, potential difference between the 2 points. That's it. Okay, ma? That's all, very simple. So that is the concept of conversion of voltmeter into ammeter and galvanometer. Okay, Seema, let us see this question. Seema, so galvanometer has a resistance of 30 ohms. Thank you. Okay, ma. So resistance of galvanometer is 30 ohms. Resistance of galvanometer is nothing but a G, no, ma? Yesterday we discussed, no? G value is 30 ohms. And current of 2 amperes is needed for full scale deflection. It means Ig value. Ig value is 2 into 10 power minus 3 amperes. That is the meaning of this. Full scale deflection means what? That is the maximum current where galvanometer can function. Are you able to understand, ma? So that value is given as 2 into 10 power minus 3 amperes. So then the question is, what is the resistance and how it is connected to convert galvanometer into? First condition is I want to convert it into an ammeter of range 0.3 amperes. And in the second condition, same galvanometer I want to convert into voltmeter of range 0.2 volts. That is the condition. Yesterday we studied, no, same galvanometer can be converted into ammeter also, it can be converted into voltmeter also. That's what we have studied, no? So for example, first of all, let us see how we can connect an ammeter. Okay, ma? Ammeter, how we can connect? For example, if this is a galvanometer, how to convert this one into ammeter, ma? So this I can convert into an ammeter by connecting a very small resistance in parallel to the galvanometer. This is the method of conversion, no? And this resistance, what we call it as shunt, very small resistance, where G is the galvanometer and G is also called as resistance of galvanometer also. This is how I can connect. So he is asking that resistance. It means he is asking us to find out this shunt value. And what is the range of ammeter? Range of ammeter, how much he gave, ma? Range of ammeter is 0.3 amperes. It means it is 0 to 0.3 amperes. That is the range of ammeter. And this maximum amount of current is also called as I also. No? All these values yesterday we studied. No? What is I? Maximum value of current that can be measured with this ammeter. And Ig is, so let us draw here only. Total current is I. Okay. Out of this I current, Ig current flows into the galvanometer. What is the remaining current? Remaining current is I minus Ig current. It flows into the shunt resistance. This is what we have studied. No? So therefore, according to Ohm's law, how can I write the equation? V1 is equals to V2. So potential difference in first branch is equal to potential difference in second branch, because these two branches, they are connected in parallel connection. That's what we have studied now. So therefore, Ig into G is equals to I minus Ig multiplied by shunt resistance S. That's all. No? So from this, what I want to calculate? I want to calculate S value only. No? Remaining all the values, are they present or not? Ig is present. Ig is given. No? Ig is also given. I is also. So everything is there. So S is equals to Ig into G divided by I minus Ig. That's all. No? Ig value 2 into 10 power minus 3. G value 30. I value again. I value. Where is I value? 0.3. So 0.3 minus Ig value is 2 into 10 power minus 3. So just to do this calculation, you will get the value of shunt resistance, so that galvanometer is converted into ammeter. And the answer which you should get is 0.2013. 0.2013 ohms. That is the resistance of shunt. Clear? That's it. Okay, ma? Now try to convert this galvanometer into voltmeter. Okay, ma? How can I convert galvanometer into voltmeter? Very simple. So when very huge resistor, it should be connected in series. This is how we connect, we convert this galvanometer into voltmeter. Now this total combination is called as voltmeter. And how I connect this voltmeter? For example, these are the 2 points where I want to find out potential difference. In between these 2 points, I connect this voltmeter. That's all. No? So therefore, here the amount of current entering is I. Okay. Voltmeter is a combination of these two. So in this one, how much current should flow? Ig current should flow. Remaining current should enter into this branch. So remaining current is how much? I minus Ig current should flow into this branch. Are you able to understand? He is asking this R value only, no? So let us take this current. So therefore, again, these two branches are parallel branches only, no? So potential difference must remain same. So what is the potential difference? V is equal to I into R. So current entering into galvanometer is Ig. Now can you say what is the total resistance of galvanometer? Chapande. Total resistance of this branch. Huh? Resistance. These two are in series, no ma? So series means total resistance G plus R. That's all, no? So from this, what he is asking? R value. So just substitute all the values, calculate R value. Okay. And what is the range of voltmeter he is asking? 0.2. So therefore this one I have to write 0.2. Ig value is already given, no? Ig value is 2 into 10 power minus 3. And resistance of galvanometer is 30 plus R. That's all, no? So calculate R value from this one. That is my required answer. Okay, ma? So find out R value. The answer which I should get is 70 ohms. 70 ohms. Okay. See, 70 ohms is a very big value, no? When compared to resistance of galvanometer, which is 30 ohms. Okay. Resistance of the external resistor is very large, 70 ohms. That's it. Okay. See, ma'am. Now we are discussing about disadvantages of ammeter and voltmeter. Okay. So their biggest disadvantage is that these instruments always show lesser reading when compared to original values. For example, if I am supposed to measure 10 amperes, it will show only 9.8 amperes only. Okay. What is the reason? Let us see. See, for example, if I take ammeter, okay, how ammeter is connected? It is connected in series, no? Clear, Nama? Ammeter is connected where, in series or parallel? It is connected in series connection only, no? So see here. For example, this is a resistor and here I want to measure the strength of the current. Are you able to understand? So ammeter is always connected in series, no? Okay. And how ammeter is made? Ammeter is made like this, no? So this is a galvanometer and this is a shunt resistance which is connected in parallel. Okay. Now what is the total resistance of this ammeter? Total resistance of ammeter is equals to G into S by G plus S. Is it correct? Why I am writing like this? Because resistance of galvanometer and resistance of shunt, they are connected in parallel connection. No? Okay. So therefore equivalent resistance is G into S by G plus S. So therefore when I introduce this ammeter into this circuit, so definitely total resistance will increase, no ma? If I don't include this one, then total resistance will be just, if I call this resistance as R, it will be R only. This is what before introduction of ammeter. Okay. Before I introduce ammeter, what is the resistance? Just R only, if there is no ammeter. But after introduction of ammeter, come on. After introduction, total or equivalent resistance of the circuit will become R plus RA. That's all, Nama. Are you able to understand? Before introducing this ammeter, resistance is only R, resistance of the circuit. But after introducing this ammeter, now these two resistors, they are connected in series connection. So total resistance is R plus RA. So what happened to resistance? Resistance has increased or decreased? Increased, no? If resistance increases, what happens to amount of current? Current value emautundi. Current reduces, no? Why? So I say that total resistance has increased. Total resistance has increased. That's all, no? If total resistance has increased, we know according to Ohm's law, I is equal to V by R, no? So therefore, I is inversely proportional to resistance. So if resistance increases, what happens to strength of current? Strength of current reduces. Are you able to understand? When I introduce ammeter, total resistance has increased. Because resistance increases, current value reduces. If current value reduces, ammeter also will measure less current. That's all, no? Actually, it was supposed to measure 10 amperes. But it will say that total current in the circuit is only 9.5. What happened to remaining current? What happened to remaining current, ma? It reduced because of increased resistance, no? So ammeter always measures lesser current when compared to original current. Are you able to understand? So right. So therefore, less current flows in the circuit. Less current flows in circuit, and ammeter measures reduced current. Okay, ma? This is the disadvantage of ammeter. So sometimes questions will be asked on this concept also, ma. Okay, and this concept is not mentioned in the books, but questions will be asked. So try to understand very carefully. Okay. So this is about the disadvantage of ammeter. Okay, ma? Now see, ma. So now we are discussing about disadvantage of voltmeter. Okay. Disadvantage of voltmeter, which you can never neglect this one. Always it will be present. Okay. So see. So here, what is the function of voltmeter? What is its function? Em chestundi voltmeter? Bolaji, eh? It measures potential difference between these 2 points, no? See here. If there is no voltmeter in this circuit, then total I current will enter into this circuit, no? And resistance is R. Therefore, what is the potential difference between point A and point B? Potential difference between A and B is I into R, no? Correct only, no? Are you able to understand? Okay, ma? So, in between points A and B, the current flowing is I, current in the circuit. Resistance between these 2 points is R. Therefore, what is the potential drop? I into R. This you know, no? But when I introduce this voltmeter, what happens? Out of this total current I, some current Ig enters into the voltmeter, and remaining current is how much? Remaining current is I minus Ig. Only this much of current enters into the circuit, or into the actual circuit. Okay. Now can you say what is the potential difference between A and B, ma? Now what is the potential difference between A and B? This resistance, if I consider it, is R. Now potential difference between A and B is I minus Ig multiplied by R only, no? Are you able to understand? Because current in this resistor is only I minus Ig, and resistance is R. Okay. Now if you compare these two potentials, what do you understand? This is without voltmeter, and this one is with voltmeter. What do you understand? Huh? What happened? Reducing? So without what? Without voltmeter. Are you able to understand, ma? So without voltmeter, current is total current, no, but with voltmeter, current has reduced. Because current has reduced, potential difference also reduces. Clear? And what potentiometer, what voltmeter will do? It will only measure potential difference between these 2 points only. So actual potential difference, if it is 10 volts, but here voltmeter will measure only potential difference is 9 volts. But actually what is the potential difference? 10. But it is measuring only 9. So that is the disadvantage of voltmeter. Are you able to understand? Right. Clear now? So this is with voltmeter. Okay, ma? With voltmeter. Right. Okay, so therefore what is the point here? We have to understand. Point is that, so voltmeter is measuring lesser values. Lesser value. That is the disadvantage of voltmeter. Okay, ma? Therefore, to remove this disadvantage, okay, ma? What we do? We use potentiometer. We use potentiometer where readings are taken. When current does not flow. When current does not flow. Are you able to understand, ma? Sima, ammeter and voltmeter, they are working in which condition? Only when current is flowing, no? Clear, no? Ammeter also works when current is flowing. Voltmeter also works when current is flowing. And when current flows, they will introduce their own resistance. So automatically readings are lesser. So what we do is, instead of this, we will use potentiometer. And potentiometer is such an instrument where we take the readings when current is not flowing. So therefore there is no concept of resistance. Okay, so therefore we will get original values. That is the advantage of potentiometer. Right now.